big part of the study of chemistry is the study of matter's physical properties and especially its chemical properties. And so today we want to talk about what physical and chemical properties are and what physical and chemical changes are. So let's start with physical properties. A physical property is something that you can measure or observe without changing that substance. So for example, I can look at something and determine what color it is. I haven't changed how the substance is made up. I can look at table salt and say, well, that's white. That's a physical property of it. The texture of something, I can determine the texture without changing what the substance is. I can determine its physical state. Is it a solid? Is it a liquid? Is it a gas? I can determine that, and I don't change the substance at all. I can determine its mass. I can determine its volume by measuring. Because you can determine mass and volume. You can also determine density. So density would be a physical property. Does something conduct electricity? Is it possible to run electricity through that? Is it a good conductor or is it a poor conductor? Is it more of an insulator? We've talked about a lot of those things already. Is it ductile, meaning can you take it and can you draw it out into a real thin, almost like a wire? Is it ductile? Is it malleable? Can I take a hammer and can I pound it into a really thin sheet? All of these things I can determine about a substance without changing what that substance is, how it's made up. Now, a chemical property, on the other hand, is something that I can't determine unless I change the substance in order to observe it. So as an example, is it flammable? Well, the only way I can determine if it's flammable is if I set it on fire. And if I set it on fire and it is flammable, I'm not going to have what I had anymore. If I take paper and I set it on fire, I'm no longer going to have paper. I'm going to have ashes and carbon dioxide and all the other stuff that a fire produces. So I would no longer have paper. So flammability is a chemical property because once I determine it's flammable, I no longer have the substance anymore. Reactivity is another chemical property. And so what I mean by that is if you've ever made one of those volcanoes, like for maybe an elementary science project where you take vinegar and you pour it into baking soda and it foams and fizzes all over the place. Well, those two react with each other, and when you're finished, you don't have baking soda and you don't have vinegar anymore. You have something else. And so the fact that they have reacted together has changed the substance. And so in order to observe that they react with each other, you don't have the substance anymore once you determine that. So I can then go from physical and chemical properties to physical and chemical changes. So a chemical change means I basically have just done something to change that substance into something else. So for example, flammability, burning is going to be a chemical change because it's going to change whatever it is you're burning into something else. It changes your wood that you're burning at your campfire into something else. It changes the candle wick on your birthday cake into something else. If you have a piece of metal and it rusts, you have then changed it from iron that is nice and good and strong into an iron oxide that is now very crumbly and isn't the same thing that you had to start with. So a chemical change changes your substance into something else, and usually it's not easily reversible. Usually it's not easy to take something and make it go back to the way it was. There are some chemical reactions that when you take chemistry, you'll find out that we can reverse them without a whole lot of difficulty. But just as a general rule, again, that's what this is. This is a general rule. As a general rule, a chemical change isn't reversible. You can't unburn something. You can't unrust something. That change doesn't turn around very easily. Now, a physical change, on the other hand, does not alter the composition of the substance. Now, it may look different, but you haven't altered the composition of the substance. So, for example, I can change the physical state of water. I can take water and I can put it in the freezer and I can turn it from a liquid into a solid. And certainly I've changed the temperature, I've changed the appearance, I've changed some of its I've even changed some of its properties because before it would flow and now that it's a solid, it won't flow. But what I've not changed is its physical composition. Each molecule in my ice is still 1 oxygen and 2 hydrogens, just like it was when it was liquid water. So I still have the same substance, I've just changed the state. Usually, again, these, and this is it's not a hard and fast rule, usually they're easily reversible, but you have to be careful with this. I mean, I can take water that I've frozen and then I can set it back out on the counter and melt it. Then I can put it back in the freezer and I can freeze it again. So change of state is easily reversible. If you boil water and you turn it into a gas, you can collect those gaseous water molecules. You can condense them, lower the temperature, and bring them back into a liquid state again. Easily reversible. Now, I have had students say, well, Mrs. Thompson, if I take a piece of paper and I cut it into confetti, that's not easily reversible. I can't put that paper back together again. That's true, you cannot, but the thing that you have to remember is that even though your paper is now in smaller pieces, you still have paper. You didn't change the fact that you have paper. It's not like you set the paper on fire and burned it. You still have paper, it's just in smaller pieces. So cutting something is going to be a physical change because you didn't alter the composition of the substance, okay? The fact that change of state is a very key physical change is something that we're actually going to spend a lot of time on, and that's actually going to be the subject of our next video.